In this video, we're going to continue learning about Pydantic, and we're going to dive deeper into what the library can offer, including looking at nested models that form parent-child relationships. We're going to look at how to use the literal class from Python's typing module in order to constrain values. We're going to look also at how to define default values for particular fields on your Pydantic model. And finally, we're going to look at a tool called JSON Schema. We're going to see how to create JSON schemas from our Pydantic model classes, and we're also going to see the other way around. We're going to take a JSON schema that's out in the wild and we're going to convert that to a Pydantic model using a tool called datamodel-code-generator. And that gives you flexibility. If you have a JSON schema in the wild, you can then create Pydantic classes automatically and start using them in your code. So let's get started. Now, I have a blog post here. This is a continuation from the previous post and the previous video that we've done. And what we're going to do is we're going to start by building nested Pydantic model classes. Now, what we had in the previous video is a student model, and that's a Pydantic model. As you can see, it inherits from the base model. And what we've got in VS Code is I've refactored this a little bit, and I've moved the model into a models.py file. So the Pydantic model now lives in this file, and it's the same as we had at the end of the previous video. It contains these fields here, as well as a custom validator function to ensure that the student is above the age of 16. Now, in addition to that, one of the fields, the department field, is an enum value, and that's defined here in this enums.py file. And finally, in the main.py file, that's where we fetch the data from GitHub, and in a for loop, we're converting each record in that data to a student model, and that data comes from this repository here. And in the previous section, we were just working with the student version 1 file, which contains a flat record for each student in the data. What we're going to do in this video is we're going to move on to the version 2 file, and that's this one here. And as you can see, each student has another field in the JSON data, and that's a modules list, and each module is modeled by an object as well. So this list of modules each contains an object or a dictionary with key value pairs, and what we're going to do in this video is we're going to validate that as part of our incoming data, and that's going to involve nesting a model within our existing student model. We have the student model here. What we're going to do is we need to add a new key here for the modules. That's going to have to reference another Pydantic model. We're going to see how to link these up in the first part of this section. So if we go back to our blog post here, we're going to go and scroll down here, and you can see one example record from the module objects. Each module has an ID, a name, a professor, and credits, as well as a registration code. Now, to help us learn more about Pydantic in this video, we're going to create the following constraints. Firstly, the ID field, it can either be an integer as it is above, or it can also be a UUID. And remember, if we go back to our student model, that has an ID too, which is always an UUID object. But for the module object, we're going to model that as either being an integer or a UUID. The second constraint we've got here is that the credits field can only have values of either 10 or 20. We can't allow just any integer for that field. It's going to have to be either 10 or 20. We're going to use Python's literal type in order to do that later on. And there's two more constraints here. If a student has not chosen a course, in other words, if the course is null, then our module list will not exist in the data. And finally, if a student has modules in the data, there must only be 3 modules for the academic year. So if we have modules in a course, we can only have a total of 3 modules. And we're going to write a custom validator function for that particular condition later in the video. So let's get started. We're going to see how to define a nested model in Pydantic. We're going to create another class here within our models.py file, and this class is going to be called module. So we'll call it module, and again, because it's a Pydantic model, it will inherit from the base model class. And just like the student model, this is going to have some fields. Firstly, it's going to have an ID field. Now remember, we said that can either be an integer or a UUID object. So we're going to model that with a union type. It's going to be an int or a UUID.UUID object. And remember, in Python 3.10 and above, this is a syntax for a union type. And this means it'll try and convert the ID that it's receiving to an integer. If that doesn't work, it will then try and convert it to a UUID. And if that doesn't work, it's going to throw a validation error. So that covers the ID field in our data. Let's go back to GitHub, and what we're going to do now is model the name. So if we copy the name of that field and go back to our model, we're going to define that as a very simple string object. The name of the module could be something like web development or machine learning. That's just going to be a string, so we'll just model it as a string. Let's move on to the next field, back to GitHub. you can see that we have the professor field, and just like the name, that's just going to be a string. Now we have two more fields in our data. Let's go back to GitHub. We have credits, and that is an integer, and we're going to model that for now as just being an integer, but remember that we said that that can only be 10 or 20, so later on we're going to change the model and make sure that that can only accept those two values. And the final field, if we go back to GitHub, it's this field here, it's the registration code. We're going to model that as a string. So that's our simple Pydantic model for the modules that we're going to have in this application. What we're going to do now is copy the name of the class, and we're going to reference it in the student model, because remember, the whole point of these nested models is that the student that we have as a record here, it contains this field called modules that itself is a list of objects. So what we're going to do is we're going to type hint the modules, and it's going to be a list of these new modules, and we can give that a default value of an empty list, which means that if we don't have a key called modules in our data, it's going to default the value to an empty list. And that's one way to define a default value with Pydantic. After defining the type, which is of course after the colon, we can then have an equal sign that references the default value. So here we have a student, and it contains a field called modules. That is a list of nested module objects. So when Pydantic receives this data from GitHub that we have here, it's going to look at the modules, it's going to look at all the records, and for each one of those records it's going to validate based on this model that we've defined above the student. And this is a very nice and Pythonic way of defining validation for complex data. You just define a class with fields and data types, and those validations will occur automatically when you try and convert your objects to these models. So what we're going to do within the main.py file, I'm going to change the source data, and this is referencing the first file that we had on GitHub. We're going to reference v2 now, so let's change that to v2 and save the file. And we can run this with python main.py, and let's see what this outputs below. If we look at the first record here, we can see that the modules is referencing a list of dictionaries. That's because we're using the model.json function. What we can actually do is we can print out the model that's here, and we can do that only for the first iteration of the for loop by breaking out after printing that model. So let's save that file, and we're going to clear the terminal and run python main.py again. So if we analyze that output here, you can see that the modules list references a list of module objects, and these have all been validated by Pydantic, because on our model class, the student model, we are now referencing a list of module objects, and Pydantic will then validate the incoming data from the nested record that you can see here. It will validate all of those fields based on the specification that we have defined here in the base model subclass, and you can see that being printed to the terminal below. Now we can see that the ID is a union, it's an integer or a UUID object. What we're going to do is go back to main.py, and we can remove the print and the break from this for loop. Above that we have a model, which is a student model after converting all that data to a student. What we're going to do is we can iterate over the modules for that particular model. So we can say for module in model.modules. Remember, modules is now a field on the Pydantic model. For each one of those, we can then print out the module's ID, and we're going to see a mixture here of integers and UUID data types. So let's print that out to the terminal, and you can see that we get integers for some of these records and UUIDs for others. So this is working. We have a union of types, and that is not throwing any validation errors. If we removed one of these types, for example the UUID, and we tried to do this again, we're now going to get some validation errors because some of these records, some of the data is not going to pass, and you can see that below. So that's just a demonstration of why we need the union type here in order to pass the validation. Let's now move on with the tutorial. Now what we're going to show in this part of the video is a very quick caveat to using union types. If we go back to the blog post, we're going to focus on this section here, and there's a statement here that it's very important to know that when Pydantic encounters a union as a type, it's going to try and cast the data in the order defined in the union. So what we have in our code, if we go back to our module, it's going to try and convert the ID to an integer first, and if it doesn't work, it's then going to move on to a UUID. But this can be a bit dangerous depending on what you're doing. If we go back to the post, let's imagine that we have a class called number, and this is a Pydantic model, and we have a field on that model called value, and we define a union. It could be an integer or a floating point number. Now the caveat here is that if we try and pass a value such as 2.2, that's always going to be able to be converted to an integer. The integer type that's defined first in this union will then convert that number to just the number 2. And that's because all floats can be converted to integers. So you need to be careful if you're doing something like this, where one type might be a subtype of another. This is probably not the behavior you want when you pass a number like 2.2 to this model. That can be represented and should be as a floating point number. So the order of the union types is sometimes important. I'll link to a section of Pydantic's documentation that talks about this issue, but I just wanted to cover that quickly. Let's now move on to the next section, and that's where we're going to define additional validations on our module Pydantic class. Now you can see here that we've got two additional validations that we want to perform on this module class. Firstly, the credits can only have the values of 10 or 20, and secondly, if a student has modules, the list must only contain 3 modules. So we're going to check whether or not the student has modules, and if they do, we're going to constrain the length of that list of modules to 3 elements. So let's start with the credit field, and we're going to go back to our models.py file. I'm going to make the terminal a little bit smaller, and what we're going to do at the top is from the typing module in Python, we're going to import the literal type, and this allows you to define a type that's constrained to the set of values you give to the literal type. And we can do this for the credits, which is an integer field, by defining a literal, and the two values that we're going to allow on this field are the values 10 and 20. So a module has credits at this university, but it can only be 10 or 20. We're not going to allow any integer number. It has to be 10 or 20. So let's save the new model, and we're going to go back to main.py. We're going to remove this for loop here, and instead we're just going to print out the model for each model in the data on GitHub. Let's now run main.py, and I'm going to expand this terminal. Now it's not the easiest to see on this terminal, but we have credits equal to 20 on this first record, and we also have another one equal to 20, and finally one equal to 10 here. So these are all passing the validations, even though they have different values for the credits, but none of them are values that are not equal to 10 or 20. What we can do is we can introduce a value that is not accurate by copying one of the source records from GitHub, and I'm just going to copy this particular module here. We're going to go back to the data, and what I'm going to do to the data from GitHub is I'm going to get the last record, and we're going to get the modules key from that JSON data, and we're going to append to that list of modules a new module, and I'm going to paste in this one here. Now the formatting is not great here, but we don't need to worry about that. But what I'm going to do is change the credits here from 20, and let's just change it to 24. And see what happens. So if we rerun the main.py file, you can see that we have an error that's coming through, and the error is related to the credits field, and it's an unexpected value. We are only allowed the values 10 and 20, but we have been given a value of 24. So that's the effect of adding this literal type to a model. It constrains the values that are applicable to that field to whatever you specify here in the literal type. And because we're passing a value that's not defined in that type, this is now throwing a validation error. So let's go back to main.py, and we're going to comment out this. Now the other thing that we wanted to do in the models.py file for the student model, we want to make sure that the modules list is either an empty list if the student doesn't have a course, or if they do have a course and a list of modules, we want to make sure that the length of this list is equal to 3. Now for the student model, we've already written a custom validator function. That was for the date of birth field. So we're going to define a new validator function here, and it's going to be for the modules field. So let's write that function here. We're going to call it validate module length. It's going to take the class as the first argument, and it's also going to take the value that's coming through for the modules field in the data. Now what we're going to do first of all is we're going to check the length of the modules that we're getting from the data, and if that's equal to 0, that's going to return false, and we're not going to continue in this if statement. But if that's true, we're going to chain an and to this if statement, and we're also going to check that the length of the value is not equal to 3, and in that case we're going to go to the if statement, and we're going to raise a value error, and to that value error we'll pass a string saying that the list of modules must have length of 3, and if we don't go into that if statement, we know that everything is okay, so we're just going to return the value. So let's go over this code quickly. What we're checking in this if statement is we're checking to see whether the module list has a length that's greater than 0, in other words, if there are any elements in the list. And if there are elements in that list, we use an and we then check whether the length of the list is not equal to 3. Now we require it to be 3 based on these requirements. So this statement, all it's doing is telling us we have a list that has a length that's not equal to 0, but that length is not equal to 3, so we're going to raise the value error. Now if we run python main.py, you can see that we get back all the data. Everything is passing this validation, but we can introduce another error here by going back to main.py, and and I'm going to uncomment this data.append statement that we had here, where we were adding one module to that list of modules for the last object in the data. Now if we append a new module to that list, it's going to take the number of elements from 3 up to 4. Now if we execute this as it was before, you can see we get the same error because of the literal that we had. So let's change the credits back to 20 and we can re-execute this code, and you can see that we get our modules error here where the list of modules needs to have length of 3. So we're appending this new object to the module list, and that takes the number of elements beyond 3, and that will then cause the validation error to throw within this validator function, and that will stop us being able to construct the object based on that data. So let's go back here, and again we're going to comment this out. Now let's finish this video with something a little bit different. We're going to look at something called JSON Schema and how it can be used with Pydantic. We can go to a web page on this. This is the JSON Schema website, and you can see that it's a declarative language that allows you to annotate and validate JSON documents. So for fields in a JSON file, you can define things like types and other constraints that are quite similar to what Pydantic models can do as well. What we're going to do now is we're going to learn how to take a Pydantic model and convert it to a JSON schema. Now there's a section of the Pydantic documentation that I'll link below the video. This is on schemas, and it's this page here, and it will tell you how to create a JSON schema from your Pydantic model classes. As you can see in the documentation, there's a main model class here, and at the bottom we use the static function schema JSON on the model class, and we can then convert the model definition to a JSON schema. And we're going to see how to do that right now with our module code. We have the module here that's defined in the models.py file. If we go back to main.py, what I'm going to do is we're going to comment out this for loop that we've been running, and below that we're going to use a print statement, and we're going to reference the module Pydantic model, and that has a function called schema JSON, and we're going to print that out to our terminal. And of course the module needs to be imported at the top here. Now let's expand the terminal, and we're going to run this code to see what it outputs. Now you can see here we get certain fields in this output. For example, the title is equal to module, that references the name of the class, and we also have things like properties. Now it's not particularly easy to read this, but the schema JSON function has a parameter called indent, and we can set that equal to 2 here, and that's going to print things out with a bit of indentation. So let's clear the terminal and rerun this, and you can see that we get a better representation of this data. The properties refer to different fields on the model. So for example, there's an ID field, and that corresponds to what we have on our model class. There's an ID, a name, and a professor, and you can see that these are represented in the JSON schema. And each field, for example the name field, has a type. In this case it's equal to string, whereas the ID is equal to an integer, or it also could be a UUID, and it uses the any of key to determine that it could be either one of those. And you can see that the credits below here, that's another field on our model, and because we're using the literal type, it specifies that as an enum where the values can only be 10 or 20. So this is what JSON schema is. It gives us a way to declaratively annotate and validate our JSON schemas, and we can produce this from a Pydantic class, and that can then be given to other developers who can develop their own code from that JSON schema. Now what I'm going to do is I'm going to save this output to a JSON file, and what we're going to do next is we're going to use that JSON to create a Pydantic model from the JSON file. And that's one of the great strengths of JSON schema. It allows you to share the schema with other developers who can then load it into their own applications, whether it's in Python or Go or C# or any other language. So what I'm going to do is copy this output here, and I'm going to paste that into a file. So on the left here, I'm going to create a new file that's going to be called JSON-schema.json, and in that file I'm going to make the terminal a little bit smaller, and I'm going to paste that code that's been output from the model's JSON schema function. So we now have JSON within this file, and this is a JSON schema file. It determines the fields that we have in our JSON, as well as some of the types and also what fields are required in the JSON. Now once you have this JSON schema file, you can put it on the internet if you have an API or something like that, and other people can then generate code based on that schema. Now what we're going to do is install another module, and it's this one here. It's called datamodel-code-generator, and in the project description for this particular package it says it's a code generator. It creates Pydantic models from an open API file. So let's copy the pip install command here, and we're going to paste that into the terminal in our virtual environment here. So we'll paste that in and run the command. And this is installing that module locally. And we're going to use the command line tools provided by that module in a minute to generate a Pydantic model based on this JSON schema. Now remember, this JSON schema is coming from the module model. When we run the schema JSON function, it generates this file, so we don't technically need to generate another model because we already have the source model, but let's imagine that we didn't. Once we've installed our library, we can clear the terminal, and this new library called datamodel-code-generator provides a command line tool called datamodel-code-gen. So let's copy the name of that. We're going to paste that into the terminal, and this is going to generate Pydantic models based on a JSON schema. So we need to give it an input file, which is a JSON file or some sort of JSON schema that's defined on the web, and the input file is going to be this JSON schema.json file that I've just saved based on the Pydantic output. So let's reference that. So datamodel-code-gen takes that JSON schema as input, and then it's going to provide an output file, and that's going to contain our Pydantic models that have been generated from the schema. So let's just call this models2.py, and that's where it's going to place the Pydantic model generated from the schema. So let's run this and see if it works. And when that finishes executing, you can see that we have a new file in this directory. It's called models2.py, and you can see at the top this comment, it's been generated by datamodel-code-gen, and that's the source file that's generated this code. And it's quite interesting to see here how it's taken that schema and it's generated this code for us, because it's not exactly the same as what we defined. For example, you can see that the credits field, that's been given a type of credits which references this 𝗖𝗵𝗽𝗀𝗀 here, and that contains the two numbers that we had in our own model, except that we defined them with Python's typing.Literal type. So this is doing things slightly different. It's using an 𝗖𝗵𝗽𝗀 instead of the literal class. And you can see we also have the union defined here for the integer and the UUID, but it's replicating the model that we have. This is quite a powerful tool. It's called datamodel-code-gen. You can take any JSON schema on the web and you can then create Pydantic models automatically based on what's defined in that schema, and that can be very useful if you're integrating with a particular service that has a JSON schema available. And we can also test if this works with the student class, which is a bit more complicated than the module because it contains validations and also a nested model. So let's delete models2.py, and within the main.py what we're going to do is change what's output here. We're going to reference the student model instead of the module. And if we run python main.py, you can see that we are getting some output, and what I'm going to do now is just copy that to a file. So I've copied that JSON and I'm just going to overwrite what's in JSON schema.json. I'm going to paste that in there. If we scroll to the top of that, you can see that this is defined for the student object, and the properties are now referencing things like date of birth and GPA, and these were defined on our student model. And remember, the student model also has a list of modules. You can see that's represented just below here. Modules has a reference to the child model in this schema. So the module type is array, and it has an items which references the child model schema. And if we rerun the datamodel-code-gen command, that's going to try and take the input from this new JSON schema file for the student and output that to a models2.py. So let's check that file and we'll see what's been generated here. You can see that we get the department 𝗖𝗵𝗽𝗀𝗀 that we had in our own code, so it's done that successfully. It's exactly the same as what we defined. And we also have the other 𝗖𝗵𝗽𝗀𝗀𝗀 for credits, and we have the child model, which is module, and now we have the student model as well, and that contains all the fields from the student, and it's included things like the constrained float for the GPA that makes the value between 0 and 4, and it's also included the optional value for the course, and also the list of modules. Now it's referencing a field function that we're going to see in a future section of this series, but everything else is by and large the same. Now there is one limitation here, of course. If we go to models.py, you can see that we have these two custom validator functions. These are Python functions defined on the model class. This is not represented in models2. We don't have these custom validator functions, and that's because with JSON schema it's not immediately clear how we take a Python function and represent the constraints in that function within a structured file such as a JSON schema. So it's not able to replicate the validator functions, but apart from that it's very good at taking the schema and creating models automatically from the schema. So that's all for this section. Here we've learned how to do nested models, we've learned about the literal type in Python, and we've learned how to define another custom validator function on our model. And finally, we've learned what JSON schema is and how we can use that to create definitions for the data in our applications, and also how we can read a JSON schema and create Pydantic models from that schema. In the next video, we're going to talk about this field function that you can see in these generated classes, and that allows you to do things that are more flexible with Pydantic. And we're also going to learn how to define config classes for Pydantic models, and these config classes classes apply model-wide configuration to fields. And finally, we're going to see more advanced ways that we can export our models to dictionaries in JSON. So far, we've only seen a complete dump of that data, but there are situations where we might not want to export everything in our model. So we can also constrain what's exported by the model.json and the model.dictionary functions. We're going to see that in the next section, but that's all for this one. Thank you for watching. If you've enjoyed the video or learned anything, please like and subscribe to the channel, and we'll see you in the next video.